Children, today we are going to start with a new chapter, that is algebraic expressions and identities. Now we have already studied some part of algebraic expressions and identities in the previous year. We are just going to brush up on those terms that we had studied relating to algebraic expressions. The first one is an equation. Now what's an equation? An equation is a condition on a variable. The condition is that two expressions should have equal value. Note that at least one of the two expressions must contain a variable, and an equation remains the same when the expressions on the left hand and on the right are interchanged. Means what happens is, what is an equation is being explained here. Now what is an equation? It's a condition, just a kind of situation which has been represented mathematically. So when we are doing something like that, we must always have an unknown factor, and when there is an unknown factor, it is termed as a variable. Now what is a variable? We already have studied a variable is an alphabet that takes place of the unknown. It can be any of the 26 alphabets that we already have in English. So any of those alphabets is variable. And then what happens, what's the specific quality of an equation? That when you interchange the expressions, then the value remains the same. How do we find the value of that unknown variable? By interchanging the numbers. We move the constants to the one side, and then we keep the variable with coefficient on the one side, and lastly we move the coefficient also and get the value for that unknown, that is the variable. That is nothing but an equation. Now the next one is an algebraic expression. What is exactly an algebraic expression? It is a mathematical statement which has coefficient, variables and or constant. Now this constant is something that can be there, cannot be there. It's not really necessary that there should be a constant in an algebraic expression. So here it's a mathematical statement. Mathematical statement, when there is a statement like if I had if I had some number of balls and then I added some more and then I got this many. So this is just a statement. When you talk about it mathematically, then you must have the numbers there. And even there is some number which is unknown. At that time, what we do is we put the variable in place of that unknown quantity, and that statement becomes an algebraic expression. Next one, a variable, like I told, it's an alphabet. It can be any of those English alphabets, 26 alphabets that we have learned. And when you go to the higher grades, you come across Greek alphabets being used as variables. So that is nothing but unknown value given some identity there. It is just something that would give you a certain idea of something being unknown, something that has to be found. So that is nothing but variable. Last, and then coefficient. It is a number that precedes the variable. Precedes, the word precedes means it is an attachment that is a prefix to this particular variable. That means it's multiplying the variable to give you the certain quantity. That is nothing but coefficient. A constant, it is a number that has no variable attached to it. Now coefficient is something that's attached to variable. That's the number. But then there are certain numbers which do not have any variable, and such kind of numbers are called as constant. Terms are components of an expression that are separated by plus or minus. When we talk about coefficient and variable, it is one term. But when we talk about coefficient, variable, and then again added to another coefficient and variable, added to a constant, so these individual components are called as terms. It is separated by plus or minus. This plus or minus is nothing but something that is a partitioning factor for the equation, the expression. An identity, it is an equation which is true for all values of the variable. All the values, put any value that you like, you still get the answer which is equal to it. Now this is an equation. Now what are the involved terms here? Now this 2 is called as a coefficient. Like I told, it precedes the variable, it comes before the variable. Then this x is called as variable, the alphabet, that's why variable. Now this 3 is called as a constant because it doesn't have any variable attached to it. These are individual terms of this particular equation. So these are called terms. Then this is nothing but an identity. Now this is an identity because if you put any value for A and B, both the sides are going to remain equal. That is why it is called as an identity. For this year, you will be having 3 identities as shown here, an identity. Now expressions, what are the expressions? Are formed from variables and constants. Whenever there are variables and constants involved, it's called as an expression. Terms are added to form expressions. Terms are added, or maybe you can call them subtraction also, that is called as an expression. Now here it is called added because negative terms can be there can be positive terms. When you add a negative term, naturally it becomes subtraction. So it's nothing but the same thing, a little different way of putting the same thing. Terms themselves are formed as product of factors. Product of factors, factors as in 2x. So here that's a product. Coefficient 2 multiplies the variable x, that's why it is called as product. Expressions that contain exactly 1, 2 or 3 terms are called monomials, binomials and trinomials. This is again something that we have already studied. If there is only one term, we call it as monomial. If there are 2 terms, exactly 2 terms, so it is called binomial, and if there are 3 terms involved, then they are called as trinomials respectively. In general, any expression containing one or more terms with non-zero coefficient and with variables having non-negative exponents is called polynomial. Now here there are specification. What is a polynomial? It contains one or more terms. All these can be termed as polynomials with non-zero coefficient. Non-zero coefficient because if you have a coefficient 0 multiplying any variable, then the answer is going to be 0. So it's of no use. You are adding nothing but 0 there. So there should be a non-zero coefficient and with variables having non-negative exponents. Non-negative exponent is something that we have already studied. Whenever there is a negative exponent, it becomes denominator. So denominator should not be a variable. If it is a variable, then it is no longer a polynomial. One of the specifications for a polynomial to be polynomial is it must have non-negative exponent. Non-negative, that means the variable should not carry minus sign with its power. In x raised to minus 3, if you have something like that, then it's no longer a polynomial. What would happen to x raised to minus 3 then? X raised to minus 3 would be 1 upon x cubed, right? 1 upon x cubed. So 1 upon x cubed means x becomes the denominator. When x becomes denominator, it is not a polynomial. So there are two specifications, one non-negative exponent and secondly the variable should not be the denominator. Like terms are formed and same variables and the powers of these variables are the same too. Now what are like terms? Like terms must have same variable and power. Power raised to what is the exponent there. So the exponents must be same as well as the variables must be same. Only then could you call them as like variables. Coefficients of the like terms need not be the same. Now here there can be a little variation. You can have different coefficients. Like terms must have only common variable and common power. The coefficient will be different, that's no problem. While adding or subtracting polynomials, first look for like terms and add or subtract them. Then handle the unlike terms. First step when you are doing any operation on a polynomial must be to get all the like terms grouped together and unlike terms grouped together. So that when you do any operation on the like terms, it is easier for you to just add or subtract them, and then you continue with the unlike terms if there are any. At that time you could just club up all the common ones and then make it as a common factor. This is the first exercise, first question. Here we have to find out the terms. Now this is our first term and this is our second term. There are two terms involved, so it is a binomial. Now these terms have x, y, z square and x, y, z as its variables. Now what are the coefficients then? The number that precedes the variables is called as coefficient. So here it is 5 and here it is negative 3. Negative 3 is a coefficient. Here first term, second term and third term. There are three terms involved partitioned by plus sign. So this is a constant, so there is no variable, so naturally there is no coefficient involved. Here variable is there but we can see no number. When there is no number involved, there is always this number that is called as 1. So here the coefficient is 1 Here again the coefficient is 1 because there is no coefficient c. When there is a coefficient of 1, we don't really put that number 1 as a coefficient. It is understood that there is 1. Now here again, this is the first term, second term and third term. The coefficients involved are 4, -4 and 1. Now here again we see 1, 2, 3 and 4 terms. First is 3, that's a constant, minus PQ, then plus QR, then minus RP. Now here the coefficient involved is -1. Here the coefficient involved is 1. Here the coefficient that we have is -1 because we have negative sign and there is no coefficient seen there. Again here we see 3 terms involved and the coefficients are 1 upon 2, 1 upon 2 and -1. Here the coefficients are decimal numbers. So there are 1, 2 and 3 terms involved and the coefficients are 0.3, -0.6 and 0.5. Like we know that positive sign is not really needed, we just have to add negative sign. Now this is how you should write the answer. What are the terms involved? What are the coefficients involved? Just make a table and tabulate all the information that we have studied. Now in the next question we have to classify the following polynomials as monomial, binomial and trinomial. Which of the polynomials do not fit in any of these categories? Now here we have 3 categories: monomial, binomial and trinomial. And if we have one term, we call it as monomial. If we have 2, we call it binomial. If we have 3, then we call that polynomial as trinomial. Then what about the terms, the polynomials which have 4 terms? Which categorize it as polynomials? As many as you want. So it's called polynomial. So we'll put color specification for each type. First we have x plus y. It is a binomial. We color it with red color so that we could see the difference. The next one is 1000. It is a monomial, so we color it, give it a green circle. Now here x plus x square plus x cubed plus x raised to 4. Now here there are 4 terms involved. When we have 4 terms, it doesn't fit in monomial, binomial or trinomial category. So what do we call it? We call it as polynomial. And here I am coloring it with a blue color circle. 7 plus y plus 5x. There are 3 terms involved. So it is a trinomial. We color it with yellow color circle. 2y minus 3y square. Now here there are 2 terms involved. So we call it as binomial, as colored with red here. The same kind of circle, red circle we have put for this. 2y minus 3y square plus 4y cubed. Now here there are 3 terms involved. So it's a trinomial. So we color it with yellow circle. 5x minus 4y plus 3xy. Again there are 3 terms involved. So like we have studied, it is a trinomial. 4z plus 15z square minus 15z square. 2 terms. So it's a binomial, coloring with red circle. Now AB plus BC plus CD plus BA. So there are 1, 2, 3 and 4 terms involved. So it is a polynomial, a generalized category. So we put it with blue color circle. PQR, there is only 1 term involved. Though there are 3 variables, they are multiplying one another. Since they are multiplying one another, we call them as one single term. Terms are divided only by plus or minus sign. There is no plus or minus sign involved here. So it is nothing but a monomial. We color it with green circle. P square Q plus PQ square plus is, now here there are 2 terms. So it is a binomial colored with red color. 2P plus 2q. There are again 2 terms involved. So it is a binomial. So we circle with red. So this is how we'll categorize it. You will have to tabulate it. That is left to you. With that we come to the end of this video. We'll continue with the exercise in the next video.